Let's now take an example of a substituted benzoic acid with an electron donating group by resonance. Let's take 4-methoxy benzoic acid. So this is 4-methoxy benzoic acid, a benzoic acid that has a methoxy group on the para position or carbon number 4. Now we do the usual is to remove, if you like, or deprotonate the carboxylic acid in order to get the corresponding carboxylate. So something like this is obtained. So this is the corresponding carboxylate. We can stabilize this carboxylate as usual by resonance, the usual resonance stabilization of carboxylate ions. Okay, that's by taking one of these lone pairs on oxygen, making a double bond between oxygen and carbon, and simultaneously breaking the carbon-oxygen double bond. If we do that, then we get this resonance form. Well, so far, no news, really. Okay, so far this is usual. So what effect will that methoxy group have on the delocalization or localization of electrons or charges and subsequent stabilization or destabilization of the conjugate base? Well, if you look at oxygen, oxygen has lone pairs. So therefore, this methoxy group is an electron donating group by resonance, which is not really new. We know already that hydroxyl groups or alkoxy groups behave as electron donating groups by resonance. That's because oxygen has 2 lone pairs. So we can use one of the lone pairs on oxygen to be donated, if you like. Here in this case, we make a double bond between oxygen and carbon. That carbon-carbon double bond must be broken simultaneously, and then we make a double bond here, and at the same time we break this carbon-carbon double bond. You could leave the carbon ion here if you like, that's one possibility, or can continue to move electrons across that carbon-oxygen double bond. If you do this, we get this resonance form now. Now, it's clear to us that there is a lone pair on this carbon, a negative charge, and there is already a negative charge. So clearly, this negative charge or electrons on this oxygen are actually localized. You can even further localize them by an additional resonance form. So you can take that lone pair, you make a double bond here, and then you break that carbon-oxygen bond. And if you do that, you get a last form, which is this one. So it's clear to us now that electrons are actually localized. The charge is also localized. If electrons or the charge, the negative charge, are localized, then the conjugate base is destabilized. Okay, so let's write that down, that electrons or the charge are localized. So there is localization of electrons. If the charge or electrons are localized, therefore conjugate base or the carboxylate destabilized. If it's destabilized, then the original carboxylic acid is less acidic, or the original benzoic acid is less acidic than unsubstituted benzoic acid itself. So this is an example, therefore, of an electron donating group by resonance. Resonance donation or donation of electrons by resonance on this benzoate results in localization of electrons or charges, which destabilizes the conjugate base. So in summary, the presence of electron donating group by resonance on benzoic acid lowers their acidity.